In this lesson, we're learning how to simplify, multiply, and divide rational expressions. A rational expression is the quotient of two polynomials, which is a fraction with polynomials in both the numerator and the denominator. Since we're working with fractions, it's important that we keep all of our answers in simplest form, and the way we do that is very similar to simplifying fractions with plain old numbers. So just like we would simplify the fraction 2/6, we write the numerator in factored form, we write the denominator in factored form, and we can cancel out the 2's since 2 divided by 2 is just 1. So then when we simplify 2/6, we're left with just 1/3. We do it similarly for rational expressions with polynomials. So x is just x. X squared we can rewrite as x times x. And then we can see that x divided by x would just be 1, and we are left with 1 divided by x. We need to talk about a restriction on the domain because we are never allowed to divide by 0. So in both the fraction we started with and the fraction we ended with, the only way we would divide by 0 is if x were to equal 0. So x cannot equal 0. So for the second example, if we have 4 x's in the numerator, we could write that out as 4 x's multiplied together, and we have 7 x's multiplied together in the denominator. The way we can simplify that is canceling 4 x's on top with 4 x's on the bottom, and we just have 3 x's left in the bottom. So this rational expression simplifies as 1 over x cubed with the same restriction on the domain. We cannot divide by 0. When we're simplifying a little bit more involved rational expressions, the best way to go about that is to factor both the numerator and the denominator. So in this first example, the numerator would factor as x minus 3 and x plus 2. And the denominator factors as x plus 2 times x minus 1. Once we have it in factored form, we're ready to cancel factors. So x plus 2 appears in both numerator and denominator. So then our simplest form would be x minus 3 over x minus 1 with a restriction on the domain of 1 because plugging in 1 would cause a division by 0 error here. But we also have a restriction on the domain of -2 because even though we crossed off the factor x plus 2, it still affects the domain of our function. So we need to look at the domain restrictions in the original expression. For the second example, we can factor that as x plus 2 times x plus 1 divided by x plus 3. And since none of those fractions are the same in the numerator and denominator, that is simplest form, and the restriction on the domain would be -3, which would cause the division by 0 problem. It would be a good idea to pause the video now to try these next two examples on your own. To begin with, on number 1, we need to factor out a greatest common factor in the numerator and the greatest common factor in the denominator, which is 8, leaving us with z plus 3. Since z minus 3 and z plus 3 aren't exactly the same, we can't cancel them, but 4 divided by 8 does simplify to 1/2. So for our final answer, we have z minus 3 divided by 2 times z plus 3, with a restriction on the domain of -3. For the second example, in the numerator, we can factor out a 3, leaving us with x minus 1. And in the denominator, you can factor out an x, leaving us with x minus 1. Since we have x in the numerator and denominator, we can cancel the x minus 1, and we are left with just 3 divided by x. Here we have a restriction on the domain of 0 because we cannot divide by 0 here or here. But we also need to have a restriction on the domain of 1 because we have an x minus 1 factor. Even though we canceled out, it still affects our domain. Here are 3 more examples of a similar idea, just a little bit more involved. So I'm going to do a couple side notes here. We have an x cubed in the numerator and an x squared in the denominator, which just simplifies to x. We have a y squared in the numerator over y cubed in the denominator, which simplifies to 1 over y. And then 24 over negative 6 simplifies to negative 4. So we are left with negative 4x divided by y as our final answer. And x cannot be 0 and y cannot be 0. For the next problem, we factor. So the numerator factors as x plus 4 times x minus 2. The denominator factors as x minus 3 times x minus 2. The x minus 2 cancels in both numerator and denominator, so we are left with x plus 4 divided by x minus 3, with restrictions on the domain being 3 and 2. For part C, I'm going to factor out a negative 4 so that I can have a positive x, so I'm left with negative 4 times x minus 3. And the denominator is a difference of squares, which factors as x plus 3 times x minus 3. The x minus 3 factors cancel, and we're left with negative 4 divided by x plus 3. The restrictions on the domain would be negative 3 and positive 3. Since rational expressions are very similar to fractions, we're going to review how to multiply and divide fractions. So to multiply a fraction, you just multiply straight across the top and straight across the bottom. So you multiply 1 times 3 and you multiply 3 times 5. Since we have factors of 3 in both numerator and denominator, we're left with 1/5. For division, what you need to do is start with the first fraction, and then to divide really means to multiply by the reciprocal. So we multiply by 3 over 2. So when we multiply straight across, we get 3, and straight across the denominator, we get 8, so our answer is 3/8. When we're simplifying rational expressions, we're also going to be doing addition, subtraction, multiplication, and division, which are the 4 basic operations on them. Having them simplified can make that much easier. So that means when you're multiplying something like this rational expression, or the 2 rational expressions you see below, we first want to factor to see if we can simplify it at all. So since we're multiplying, we have to multiply straight across the numerator and denominator. So the first expression factors as x plus 3 times x minus 2, and that is still divided by x minus 5. And then we have times the second expression factors as x plus 5 times x minus 5, divided by x plus 3 and x plus 1. Since to multiply, you multiply straight across and bottom, you can really just make this one fraction with multiplication all the way across. So the x plus 3's cancel and the x minus 5 cancel. And we are left with x minus 2 times x plus 5 divided by x plus 1, with restrictions on the domain being negative 1 from the x plus 1 factor, and negative 3 and 5 from the other 2 factors that we canceled out. You may want to pause the video again to try the next problem. Our first step is to factor every polynomial we see. So we can factor out a 2 from 2x minus 8 to get 2 times x minus 4. In the denominator, we have x plus 4 and x minus 4. And multiplying straight across, we have x plus 4 times x plus 1, and that's divided by x plus 4 times x plus 4. When we cancel our like factors, you can cancel x minus 4 and x plus 4. So in the numerator, we are left with 2 times x plus 1. And in the denominator, we have two factors of x plus 4, which is x plus 4 squared. The restrictions on our domain are -4 and 4. In this division problem, we again begin by factoring. So in the first fraction, I'm going to factor out a negative to leave us with negative x minus 2. And in the denominator, we have x plus 1 times x plus 1. Then we are dividing by the fraction in factored form, x plus 5 times x minus 2 divided by x plus 1 times x minus 1. And now to divide by fractions, what we really need to do is multiply by the reciprocal. So what we have is negative x minus 2 divided by x plus 1 times x plus 1, and then times the reciprocal, so times x plus 1 times x minus 1 divided by x plus 5 times x minus 2. Now we are ready to cross out the like factors in the numerator and denominator. So we have x minus 2 and we have x plus 1 that can cancel. Then we are left with negative x minus 1 divided by x plus 1 times x plus 5. When we talk about the restrictions of the domain, it becomes slightly more involved when we're dividing. So we need to look at our final answer. Here we can't have x equal to -1 or 5. So there are two, or -5, there's our two restrictions. We also need to look at the factors that we canceled. So we can't have x equal to 2, and we already have x equal to -1 as a restriction, so we can't have x equals 2. And we need to look at our original fraction that we were dividing by and look at its denominator to see what division problems we would have there. And there we would have positive and -1, so we need to add a +1 to our list of restrictions. For the last division problem, we again start by factoring. So we can factor the first problem, or the numerator of the first fraction, as x plus 4 times x plus 1. We can factor the denominator as x plus 4 times x minus 3. And then we are dividing by the fraction, which can be factored as x plus 1 times x minus 1 divided by 2x times x minus 3. Then we know this really means we are multiplying by the reciprocal. So we have x plus 4 times x plus 1. We're dividing by x plus 4 times x minus 3. And we are multiplying by the reciprocal. So the 2x times x minus 3 is now in the numerator. And the x plus 1 times x minus 1 is now in the denominator. When we cancel like factors, we can cancel x plus 4, we can cancel x plus 1, and we can cancel x minus 3. This leaves us with a final answer of 2x divided by x minus 1. The restrictions on our domain are 1, -1, coming from the denominator here, 3 and -4, coming from this denominator, and then we also have 3 and 0 coming from this denominator, so we need to add 0.